In 2015, there was a huge excitement in the space community. That is because, after a 9-year journey, the New Horizons space probe flew by Pluto and its moons. So, what did the New Horizons probe see and discover using its flyby of the Pluto system? And what has it been doing since then? What is Sputnik Planitia? And why is it so popular in the scientific community? What is the significance of Arrokoth? Why Pluto is no longer the 9th planet of our solar system? Today we will explore all the highlights from the New Horizons mission to the Pluto system and beyond. Flyby. The goal of the mission was to get to Pluto as soon as possible. It also discovered a dispersed belt of asteroid or comet-type objects beyond the orbit of Neptune, known as Kuiper Belt. On its way to Pluto, it used Jupiter as a trial run for its systems. After this successful trial, New Horizons went into hibernation mode to prevent the wear and tear of its instruments. Leading up to its approach in 2015, the team turned the systems back online, and every day the spacecraft sent back images of the Pluto system. This was an incredibly exciting time for enthusiasts following the story. It shows Pluto is remarkably tiny, much smaller than our moon. On the 14th of July, the New Horizons probe made its closest approach, at only 12,500 kilometers from the surface of Pluto. Pluto's biggest moon, Charon, orbits very closely. They actually both orbit around a point in space and are tidally locked to each other. This means that if you stand on one, the other won't move from that point in the sky. This is very unusual because usually only moons are tidally locked to their parent planet. Sputnik Planitia. The biggest visible feature on Pluto is this giant heart shape, which wowed the world when it first came into view. It has since been named Sputnik Planitia. It is the size of Texas, and it has a strong color contrast to the surrounding area. This is because it is a giant ice plain. On average, the temperature on the surface of Pluto is negative 229 degrees Celsius, which means water ice could be rigid and brittle. On the other hand, nitrogen ices at this temperature act like water ice on Earth, meaning it can flow as glaciers. This can especially be seen around the edge of the heart, glaciers flowing into the gaps around the craters and mountain ranges. The ice plains themselves have giant polygon shapes across the entire area. There are also no craters, which means it must be a relatively new feature, or a feature that is being continually renewed. It is perhaps only 10 million years old. Sputnik Planitia could be compared to Greenland and Antarctica, in that it controls the climate of Pluto heavily. It could have formed from an impact, and ice has filled the crater in from a potential subsurface liquid ocean. Atmosphere on Pluto. The most impressive discovery was that New Horizons was able to confirm that Pluto has an atmosphere. Pluto's atmospheric density can vary by many orders of magnitude over the course of its 248-year-long seasonal cycle. Due to Pluto's small size and weak gravity, the atmosphere appears to extend high above the surface. The atmospheric pressure on Pluto, on the other hand, is exceptionally low, roughly 10 microbars, or 100,000, to a million times weaker than the surface pressure on Earth. The other fascinating discovery is that it has up to 20 haze layers. Haze layers themselves were not unexpected, but the amount of them was. Pluto's surface is believed to be an ocean of liquid water. It was originally thought that Pluto formed cold, being so far away from the sun. However, evidence from the New Horizons suggests that this is not the case, but rather it started off hot. This means it's always had an ocean. And if that is true, then there is a case that habitability on Pluto may be good. This fact indicates that there may be more habitable worlds out there in the Kuiper Belt. But how do we know that it had a hot start? There is evidence of expansion, not contraction, on its surface. The cracks show that the crust is moving apart, not folding over itself. If this is true, it would have had enough thermal energy that it was once an ocean world. This really puts a new perspective on how the solar system is formed. New horizons beyond Pluto. New Horizons started heading deep into the Kuiper Belt. It had traveled so far from Earth that when it looked at our closest star system, Alpha Centauri, it was in a clearly different place from New Horizons' perspective than from ours. One of the important discoveries was Arrokoth. So what is Arrokoth, and why is it significant? Well, it was initially nicknamed Ultima Thule. It has some unique characteristics and mysteries, like it has a pristine and relatively unchanged nature. This primordial state raises questions about the processes that have preserved its surface features and composition over billions of years. The surface of Arrokoth exhibits intriguing features such as smooth regions, pits, and ridges. These surface characteristics suggest a complex history of geological processes, including impacts, sublimation, and possibly even tectonic activity. Analyzing Arrokoth's composition, including its ices, minerals, and organic compounds, can provide clues about the materials present in the outer solar system during its formation. This information is crucial for understanding the distribution of volatiles and building blocks of life in the early solar system. Studying further can also help scientists unravel the frequency and nature of impact events in the Kuiper Belt over geological timescales. New Horizons, Other Discoveries. The mission provided detailed images of Charon, Pluto's largest moon, showing a varied terrain with canyons, craters, and a dark region informally named Mordor Macula. Charon's geological complexity surprised scientists. Beyond Arrokoth, New Horizons studied other Kuiper Belt objects, providing valuable data on their compositions, surface properties, and orbital characteristics. These observations contribute to our understanding of the Kuiper Belt's population and evolution. It searched for rings and additional moons around Pluto, but found none within the mission's detection limits. This information helps refine models of Pluto's system dynamics. The mission also studied space weather near Pluto, including interactions between the solar wind and Pluto's atmosphere, captured images of distant objects, stars, and galaxies during its journey beyond Pluto, contributing to astronomy beyond the solar system. These discoveries represent a small sample of the wealth of scientific data gathered by the New Horizons mission, which continues to be analyzed and interpreted by researchers to deepen our understanding of the outer solar system and beyond. But why is Pluto out of scope to classify a planet? Primary reason was due to a redefinition of what constitutes a planet by the International Astronomical Union, IAU, in 2006, which included 3 criteria. A. The object must orbit the Sun. B. The object must have enough mass for its gravity to make it nearly round in shape. C. The object must have cleared its orbit of other debris. Pluto failed to meet the third criterion because its orbital overlaps with that of Neptune, and it shares its orbital neighborhood with many other objects in the Kuiper Belt. As a result, the IAU reclassified Pluto as a dwarf planet. Hope you like this journey towards Pluto and beyond. Please let us know which of the facts intrigued you the most. Thanks for watching.